Today we are going to begin our study. We'll be spending the entire unit talking about, and we're going to start by exploring these quadratics with later in order to we understand the properties that the equation has for the parent graph. So you can see up at the top we've got functions of the form y equals x squared. That is our parent graph. That is the basic quadratic function that you can have. So that is going to be our parent graph. So we're going to graph it on your graphing calculator in a standard window. So on your graphing calculator, turn it on, go to your y equals screen and clear out anything that you don't need and type in y equals x squared and then hit graph. Again, if your window is not standard, then do the zoom 6 so that you can get it to a standard window. Now, we are going to be talking about a whole bunch of different properties of our quadratic functions. We're going to be needing to identify the vertex, the domain, the range, and the line, or sometimes called axis of symmetry. Now, the vertex is either the highest point, the maximum, or the lowest point, minimum, on the graph. The line of symmetry is going to be the vertical line that goes directly through the middle of your parabola. So you should now have your graph on the graphing calculator. One trick we are going to learn today that is very helpful for the future is that when you are graphing something in the graphing calculator and you want to see actual points, and meaning we don't want just a sketch of what it looks like because we know that it's U-shaped, but we want actual points to look at. That means that we are going to need something that's going to kind of give us that T-chart. The way you can do that on the graphing calculator is by pressing the second button. So I'm going to write this down. To get the T-chart, you're going to press second, and then you're going to press graph because that brings up the tables. So second graph, second table, and you should now have a T-chart of x and y values that you can write down. So we're going to come up with some key points here, and we've got ones that will actually fit on the graph. We've got -2, 4. We've got -1, 1, 0, 0, 2, 4. Everything else would be off of this graph since we're counting by ones there, as you can see. Oops, I skipped one. Silly me. Right in here, I knew. I was like, why are there only 4 instead of 5? I skipped 1, 1. That should be in the middle there. All right, so we've got some key points. That's helpful because, again, we want an actual graph. We don't want a sketch. So if we graph all of those points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, you can see your shape coming in. Remember that parabolas are U-shaped. Do not make these look like absolute values. You need to make the tops or bottoms rounded. So when you connect them, I always suggest connecting at the bottom first and then working up both of the sides individually. So there is my parent graph, y equals x squared. When we're looking at it, hopefully you can see that the vertex is 0, 0. And the line of symmetry is the y-axis, or you can also write it x equals 0. Now, domain and range you did in Algebra 1, but I want to make sure that we remember what those mean. Domain are the x values that are possible. So possible x values, and the range are your possible y values. So domain means what x's are possible. So you look along your x-axis, and obviously you've got values in here, but you've got arrows, which means that this is going to continue going on and on and on, And the x values are going to get bigger on this side and smaller on this side, which means that my domain is all real numbers. X can be anything. There's nothing that I am not allowed to pick for x. I can pick any number I want for x to put in here. So my domain is going to be all reals. And that's the symbol for all real numbers. If you want to write out the words, you can. Another way to write all real numbers in upper level math is by putting limits on it, saying from negative infinity to positive infinity. So two different ways to write it. It's just saying there is no limit on the minimum x, there is no limit on the minimum y. The range, y values. If you look at the y-axis, you'll notice that there's nothing down here. And no matter what I pick for x, it's always going to be in this direction. There's never going to be anything down here. So that means that my y values start at 0, because this is my lowest point, my minimum. They start at 0 and they get bigger, which means you can either write it as all real numbers greater than or equal to 0, or you can write it this way: starts at 0, bracket means includes, and there is no limit on the high, so it goes to infinity. So two different ways to write that. Okay, so this is your parent graph, and we are going to use it to explore some of the other properties. So on 2a and 2b, graph each function on your calculator, then graph it on the coordinate grid. So you're going to be doing the same thing, typing each one in, going to the table, and then filling out the information. So I'd like for you to go ahead and 2b on your own and then come back to check your work. All right, so 2a, the points that you have 0, 4, you have 1, 1, you have 2, 0, you have 3, 1, and you have 4, 4. So hopefully your graph looks like this. You should have found the vertex to be 2, 0. The domain, just like on the parent graph, x's keep going in all directions, so either all real numbers or the infinity notation. The range, also the same. The y values start at 0 and get bigger. The line of symmetry is different. The line of symmetry is here. That's a vertical line at x equals 2. For the other one, you've got points at -6, 4, and -5, 1, -4, 0, -3, 1, and -2, 4. So again, when I connect these, make sure the bottom is rounded. There you go. Vertex -4, 0. Domain, again, x can be anything. There's no restriction on the x, so all reals. Y values, again, I'm looking at my y-axis here. I don't see anything below this minimum point. So that minimum point is where y is 0. So we're starting at 0 and getting bigger. Here, my line of symmetry is right there. X equals -4. All right, 2c, summarize your observations from the graphs above. If a quadratic function is of the form y equals x minus h squared, what does the h in the equation have to do with the vertex of the parabola? So you're looking at this value as well as the value of the vertex. This value of the vertex. I'm not going to give you that one, but you better make sure it's answered for tomorrow. So you don't know, take your best guess, but what is the relationship between this h and the vertex of your parabola? All right, 3 and 4, we're doing the exact same thing, but we're looking at a different property. Now, instead of looking at h, we're looking at k. So equals x squared plus k are the ones that we're doing here. So take the time, get into your graphing calculator, clear out what you have. You have to practice graphing these and looking at the table. If you just watch me fill it in and copy it down, you're not learning how to use your graphing calculator and you're not going to be able to do it on your own. So please graph each of these in your graphing calculator and look at the table to get your graph. So pause it again, do these next two, and then come back to check your work. On this one, when I looked in the table, I've got some points, -2, -1. I've got -1, -4, 0, -5, 1, -4, and 2, -1. So it looks like this. My vertex right here is at 0, -5 is its ordered pair. Domain here, again, my x's keep going everywhere. There's no limit on the x-axis. It keeps going, so all real numbers. My range here is different. If you look at my y values for this function start right here at the vertex, and they get bigger. But that's not 0 and bigger. That's y equals -5 and bigger. So the range here should be all reals greater than or equal to -5. Line of symmetry is the y-axis, or x equals 0, whichever way you want to write it. 3b. I can only fit 3 points on this graph. I've got 0, 4, and I've got -1, 5, and +1, 5. The rest of them would be off my graph, so that's all that I can fit there. My vertex is at 0, 4. Domain, again, there's no restriction this way. It keeps going this way. So domain is all reals. Range, my y values start here at the vertex. That value is 4, and they get bigger, so it's all reals greater than or equal to 4. My line of symmetry, again, there is the y-axis, or x equals 0. All right, another conclusion for you. Summarize your observations. If the quadratic function is in the form y squared plus k, what does the k in the equation, so here the -5, here the +4, have to do with the vertex of the parabola? So look at your vertex, look at your k, and fill that out. Again, do not leave that blank. You need to fill that in. All right. Last ones that we are going to do here together. We've got y equals 2x squared, 1/2 x squared, -2x squared, -1/2 x squared. So again, you're clearing out your y equals screen. You're going to graph each of these using your graphing calculator. Use the table to get your exact points because these are graphs, not sketches. So pause it either one at a time or do all of them and then unpause, whichever works best for you, but come back to make sure that your answers are correct. So on y equals 2x squared, you should have a point here at the origin at 0, 0. You should also have a point at 1, 2, and at -1, 2. And the other ones would be off the graph. So connect with a U shape. My vertex is at 0, 0. Domain, as has been the case, is all real numbers. My range, the y value starts at 0 and it gets bigger, so greater than or equal to 0. All reals. My line of symmetry is x equals 0, or the y-axis. 1/2 x squared. That one I also have a point at the origin. Then I've got 2, 2, and negative 2, 2. So connect it. Vertex is at the origin again. Domain is still all reals. Range starts at 0 and gets bigger, so greater than or equal to 0. Line of symmetry is still x equals 0. Now notice that C and D are the same things as A and B, except they're negative. If you haven't done these yourself, again, pause it again. If you already have, then continue checking. On 4C, we've got 0, 0, 1, negative 2, negative 1, negative 2. So it looks like this. A vertex at 0, 0. Domain of all real numbers. Range, careful here. The range starts at 0, but for the first time, those y values get smaller, not bigger. So the range here is less than or equal to 0 because the y values are smaller than or equal to 0. My line of symmetry is still here, the y-axis, or x equals 0. For 4D, on my graph, I've got 0, 0, 2, negative 2, negative 2, negative 2. All right, vertex 0, 0. Domain, all reals. Range, again, starts at 0 and gets smaller again, less than or equal to 0. And the line of symmetry is x equals 0. Now, notice that A and B have the exact same main points: vertex, domain, range, line of symmetry. Those are all the same, but those are not the same graphs. Obviously, the points are different. They look different. Same with C and D. So you've got two observations here. One, if the quadratic is of the form y equals ax squared, so we're looking at what the value of a does to the vertex of the parabola. So you're considering two things. What does the value, the sine of a, do to the parabola? And what does the size of a relative to 1, meaning if it's bigger than 1, smaller than 1, all of those. Once you have filled that in, one last question for tonight to take it a bit further and think. If you drew lines that connected the vertex to the next 2 points, so I'm going to do that in red here. If I connected these and made lines instead of a parabola, what about those lines here would relate to your A a little bit? So think about that, and that is it for tonight. Again, you do not have to finish 5 and on. That's what we're going to be working on in class tomorrow. If you get really excited about it, I'm sure you can start to work ahead if you would like. But that is through number 4 is all you are required to have done for tomorrow. That is it.